So number 14 on the previous lesson. So I gotta write the rest of this good. So 2n greater than or equal to negative 7. Subtract the quantity n plus 4. And that right there, subtracting that n plus 4, that's the one that we've struggled with at times, and we want to make sure we get right when we simplify. So how do we work with the right-hand side?
Add the n.
Well, we can't when it's in parentheses.
We have to get rid of it.
We got to get rid of the parentheses.
Plus they're going to be negatives.
Yeah, so the negative 7 is the same, but they're going to be negatives because this negative distributes.
Ooh,
It changes both of them, and that's where we get hung up. So many times we do not change the second term. When we distribute, you got to distribute the whole thing. So there now, with that, what would you do? Well, that's subtracting n already. So it's like adding a negative and adding a negative of each of these. So if we add an n, then we have to take this and this and put them together. How much is that?
Negative.
How much?
Negative.
Well, if you went negative 7, and now you go negative 4,
Negative.
it's a negative 11. Then when we divide, we don't have to switch the direction. So this is negative 2 and, I'm sorry, negative 3 and 2/3. The negative 11/3. Was that a review problem? That was a review problem, yeah.
I didn't put the 7 down. I didn't put the negative 7 down. I just made it negative 7 on it.
Do you understand?
Multiplying it.
Do you understand what you did and what you needed to do?
Yeah.
Does this make sense now? Staring at it won't make it happen. Don't be afraid to ask for help. But this is the trick right here. You know, you can think of that as the same as negative 1 multiplied by. Because that's really what a negative in front of something is like. If you can see this, like if I had 4, and then I put a negative out front, that equals negative 4, right? Yeah. So it's the same as saying negative 1 times 4, because negative 1 times 4 just changes. Okay. You have 18 also. Were you able to write that pattern? Did you do it with one variable? Or no, 2. You had to do it with 2 of them, didn't you? So it looks like it would be negative x minus y equals y minus x. Yeah, negative x minus y equals y minus x. And if you look, see, these patterns that they have you come up with and look at are patterns that we use a lot in this class and in other math classes. So if you look at how that negative changes each of these, it becomes a negative x, and then a negative times a negative is a positive y. And that's the same as this. So let's go back to that right there. If you had a negative n plus 4, you could think of it as negative n and negative 4, but you could also write it as negative 4 minus n. And that's what that is showing us over there. It's a very similar type of pattern. All right. So shall we go on? We are going on. Equivalent formulas. So we've been doing things like looking at tables to see when equations come up with the same answer. Like comparing, God, what was it, we were comparing Acme printers and best printers or something like that, copy companies. And, you know, we had expressions for both of those and we set them equal to one another. So we were finding out when is one a better buy than the other, when do they charge the same price, you know, for how many copies. We've been doing a lot of that with tables. We've been doing it with graphs. And we've been doing that for you to be able to picture and see what happens with these expressions. But now what we're gonna do is we're gonna go more towards just taking an equation or a formula and manipulating it and changing it. And one that I know that I've done with you way back is this one. D equals RT. What's that a formula for? Do you remember? D equals RT, commonly used. It's not in the book, I don't think, at least not right here. What does D stand for, do you think? Could be diameter, but actually they use a capital D for diameter. So what's another D word that we do in distance? Okay, so distance equals, what's R? Rate?
And time.
Time. Distance equals rate multiplied by time. So the distance that you travel in miles might be your rate in miles per hour multiplied by your number of hours. But this formula might be used if you knew how fast you were going and how long you were traveling that fast. So if you're going 60 miles an hour for 2 hours, how far do you get? 120 miles. If you go for 10 hours, you get, at 60, you're getting how many? Yeah, 600 miles. These multiply them together. But let's say you knew how far you went and how long, then you would have to calculate what your speed is. So what is rate equal to if we start with D equals RT? How do we find rate alone? So that's how fast you're going, right. So how do we organize the D and the T, the distance and the time, to figure out how fast we're going? So yeah, if you divide by T on both sides, then you get R all alone. So your rate of speed is equal to your distance divided by your time. And that makes sense. Rate is distance, miles, divided by time, hours. So what's T equal to? What did you say, Jackson? D divided by R. See, if we took distance is equal to rate multiplied by time. To get time alone, we divide by rate and then rate. Distance over rate. So here we have 1, 2, 3 equivalent formulas that involve distance, rate, and time. So all we did is we used inverse operations to manipulate or change them. That's what we have to do with this lesson. This one's straightforward. There's just multiplication and division to consider. But when we have more operations like addition and subtraction, or maybe even square roots and such, we've got to watch our order of operations much more carefully. So let's just take this first one here and work through it. Example number 1. So they give us a formula here, F is equal to 9/5 C plus 32. So what does that formula look like it's for? You should be somewhat familiar with this one. I know you've seen it. What do F and C stand for? Yeah, Fahrenheit and Celsius. So if you knew the number of degrees Celsius, you multiply it by 9/5 and you add 32, you get what it's equal to in Fahrenheit. This is the formula for Celsius to Fahrenheit. But if you knew what Fahrenheit was, what do you do to Fahrenheit to get to Celsius? So what we're doing here is we are going to rewrite this formula for C. That's how it's said. So we want to rewrite this is how it gets said. We are going to rewrite in terms of F. So whenever they say in terms of, then that becomes the variable that you have to do the math to. That becomes the independent variable. And then your answer is the dependent variable. So that when we're done with this, it has to be for C. C equals, and then all of the math that we do to F to calculate what C is. So all we have to do here is use inverse operations to get ourselves so that this says C equals. So what do you think the first step would be to get C all alone? Well, this is just like it's like a two-step equation. Yeah, subtract the 32, and then rewrite it. It's just that you have variables, so you gotta pay attention to that. So you have F subtract 32. Is equal to this, because those zero cancel. So now, last step. Divide by 9/5, which is the same as multiply by what?
5/9.
Reciprocal 5/9, yes. Now, the key over here, because we're doing the entire right-hand side, which is only made up of 9/5 C, and that cancels. When we do the entire left-hand side, we don't just say 5/9 times F and then subtract 32. It has to be times the entire amount, so that gets put in parentheses. So if we were to rewrite all of this, we would say that C is equal to 5/9, the number of degrees Fahrenheit, take away 32. Uh-oh. What do I do with my cap? I'll put the purple one on while I'm using the purple one. Oh, it's a different cap. Oh well, so it is. Okay, next one. The second example. You say the volume of a cone. So, let me grab a cone. Here's a cone. This is a cone shape. Cone's got a circle, it's got a base. Whenever you see any shape that has a circle or something that like an oval or anything that resembles a circle, pi is going to be a part of the equation. Like circumference of a circle, area of a circle, all these things. So with a cone, volume is equal to, they say 1/3, what's the order they write them out in? 1/3 pi r squared. they say 1/3 pi r squared h, 1/3 times pi times r squared times h. So h is the height of the cone. Radius is the radius of the base. We're going to take 1/3 times pi. But what we need to do is we need to rewrite this thing for h. So if you knew the radius and you knew what volume you needed, how tall of a cone would you need to build? So when we're all done with this, it has to be h is equal to. So we have to do inverse operations to get h alone. So tell me, what do you think would be the first step? Get rid of the 1/3. So how do you get rid of the 1/3? You can't subtract because everything's being multiplied here. All of these are multiplication. Multiply by the reciprocal, which is 3 over 1. And then the 3's and the 1's, 0 cancel, or they simplify to 1. So this ends up being 3, but we don't have to write 3 over 1. But you could if you wanted to. We'll just put it there. So now what we have is we have 3v over 1 is equal to pi r squared h. Now what? How do we undo multiplication? Divide. So what do we want to get rid of here? We have to get it down to just h. Pi. What else? R squared. So then if we come over here, I'm going to write this with a little bit more room. We also have to divide this side by pi and by r squared. So pi is gone, r squareds are gone. From the right-hand side, you're left with h. So 3v divided by pi r squared, 1 times pi r squared, same, is equal to the height. So it's the same formula, but in this case it's written for h in terms of volume, pi, and radius. Okay. And the last one. Sometimes we're given equations and we need to put them into the graphing calculator, but they're not in a form that we need to have to put into the graphing calculator. So to use a graphing calculator, everything starts out as y equals, right? So the equation needs to be written for y in terms of x. So what that means is you're going to have to write things possibly in slope-intercept form, like this. And then there's another form that I'm going to teach you later on this year called point-slope form, which is really, really handy. It's the easiest of all of them to use. But we've also looked at standard form of an equation. So the last example here, they give us an equation which is written in standard form. 5x minus 2y equals 100. And they say you need to enter that into the graphing calculator. Well, it won't go in like this. It needs to be in this form here. So what we have to do is we have to manipulate this so that it reads y equals. We have to solve this equation for y. So it's just like all of the inverse operations we've been doing all along. But in the end here, it's going to read y equals. So, first step. add 2y, you could do that. And on the left, you'd have 5x, that 0 cancels. And then you have 2y plus 10. Now what? Gotta talk loud through that mask. Well, yeah, you can get rid of the 10 because it's just being added. So you could subtract it, then it's 0 cancels from both sides. Now we have 5x minus 10 is equal to 2 times y. Now what? For everything that we have to, that we are trying to change, we have to use its inverse. So if you look at this, what are you trying to change? Which of these three terms do we want to change? We want to change the 2y and make it into 1y. And that has multiplication. So you have to divide, yeah. If you divide by 2, you'll get y. But then everything else has to be divided by 2. So this is the trick here. Every term will be divided by 2. And terms, remember, are separated by addition and subtraction. So 10 divided by 2 equals 5. And then 5 divided by 2 is just 2.5 or 2.5. And since you're going into a graphing calculator, yeah, this time you're going to need 2.5x. However, sometimes you come up with weird things like 7/3. You can't change that to a decimal and graph it. If you were going to do that, like let's say you came up with 7/3 x, and you had to put that into a graphing calculator. This is how you do it. When you do, like if this is y equals, you get to the y equals in the calculator, and you do parentheses, 7 divided by 3, parentheses, and then you do the x. That will make it so that it graphs out well. So this equation right here, flip it around, y equals 2.5x minus 5, is exactly the same as this equation. They're just written in different forms. So I think that's going to get you out of this. Yeah, you got to be able to do this work now.